Okay, so welcome to my channel. Today I am going to discuss the remaining problems of Laplace transform chapter from mathematical physics book written by H.K. Das. Okay, so in previous video I have discussed up to 8 from the exercise 46.1. Okay, so in this video I am going to discuss the remaining problems. Okay, so let's start. So you can see here that the question 8 I have discussed earlier. Okay, so now I am going to solve the question 9. Clear? Okay, so you have not seen the previous video. If you have not seen the previous video, then please watch. Okay, I will share the link in my description box. Okay, so here 9, the function given that sine hyperbolic q t. Okay, so Laplace transform. Fine. Now we know a formula. Okay, sin q t equal to 3 by 4 sin t minus 1 by 4 sin 3t. Okay, so at first I am going to replace this by hyperbolic function. Okay, so sin hyperbolic qt equal to 3 by 4 sin, sorry, blur problem. Okay, so sin hyperbolic t minus 1 by 4 sin hyperbolic 3t. Okay, now I'm going to take the Laplace. Okay, L of sin hyperbolic qt. Okay, now substitute this. L of 3 by 4 sin hyperbolic t minus 1 by 4 sin hyperbolic 3t. Okay, clear? Okay, now this 3 by 4 constant term. Okay, it will removed. Okay, after that L of sin hyperbolic t, and you all know that L of sin hyperbolic t equal to a by square minus square. Okay, so from here I am using the formula. Okay, so we get 3 by 4 1 by square minus 1, because here is 1. Okay, this a equal to 1. Now minus 1 by 4 sin hyperbolic t, here t by square minus 9. Clear? Okay, now the simple calculation. So 3 by 4 1 by square minus 1 minus 1 by square minus 9. Okay, so her simple calculation. So 3 by 4 square minus 1 into square minus 9, and here square minus 9 minus square plus 1, this is square removes minus 8. So 3 by 4 into minus 8 by square minus 1 into square minus 9. Clear? So here minus 6 by square minus 1 into square minus 9. Okay, now we are going to solve the question number 10, and here it is given that the level I have to transform the given function is cos t cos 2t. Okay, so Laplace of cos t cos 2t. Okay, simple calculation. So here cos a cos b. Okay, so 1 by 2 L of cos 2t plus t 3t plus cos t 2t minus t. Clear? Cos t. Okay, so from here 1 by 2, you all know that L of cos 3t equal to s by square plus 9. So from here 1 by 2 s by square plus 9 plus s by square plus 1. Okay, I'm saying again that if you have not watched the previous video, then please watch this. After that come to this video, otherwise you will face problem. Okay, so 1 by 2 s into square plus 1 plus s into square plus 9 by square plus 9 into square plus 1. Okay, now 1 by 2 into sq plus s plus sq plus 9s by square plus 9 into square plus 1. Okay, so from here we can write 1 by 2 2sq plus 10s by sq square plus 9 into square plus 1. So equal to s into square plus 5 by s into square plus 5 by square plus 9 into square plus 1. Okay, now I am going to solve the question number 11. Okay, so here it is given that cos hyperbolic 80, okay, sine hyperbolic 80, clear? Okay, sine hyperbolic 80, cos hyperbolic 80. Fine. So I will transform this hyperbolic function to exponential function. Okay, so e to the power 80 plus e to the power minus 80 by 2 into sine of 80. Now split it. Okay, so e to the power 80 sine 80 by 2 plus e to the power minus 80 sine 80 by 2. Now take Laplace. Okay, so L of e to the power 80 sine 80 by 2 plus L of e to the power minus 80 sine 80 by 2. Okay, now I will use the shifting theorem. Okay, I think you all know this because in previous video I have discussed about this theorem. Okay, so from here 1 by 2 outsider. Okay, so I am taking this common. Okay, a by s minus a whole square plus a square, because here the constant term is a and a by s will be replaced by s minus a because of e to the power 80 plus a square. Okay, plus a by s plus a. Why s plus a? Because here the constant term is minus a, so s minus of minus a, so s of plus a, so s plus a the whole square plus a square. Clear? Okay, now simple calculation 1 by 2, and here you can see s minus a whole square plus a square into s plus a whole square plus a square. Okay, so here a into s plus a whole square plus a square plus a into s minus a whole square plus a square. Clear? Okay, from here I can write a will be common and split it. A square plus 2as plus a square plus a square plus a square minus 2as plus a square plus a square, so 2a square. Clear? By s minus a whole square plus a square into s plus a whole square plus a square. Okay, so here this will be vanished. Okay, so 1 by 2 a into a square into a square, a square, a square, so 2 square plus 2 square, 2 square, 4 square plus 4 square by s minus a whole square plus a square into s plus a whole square plus a square. Okay, okay, so from here we can write this half. From here I can take common 2 into a square plus 2 a square, so 2 will be vanished, so a into a square plus 2 a square by from here you can write s to the power 4 plus 4 square. Okay, uh, make this calculation. Okay, okay, this is answer. Okay, if you face any problem then mail me, send mail, I will solve it. Now I am coming to the number 11, sorry, number 12. This is the problem number 12. Okay, so this is hardcore math. I am going to solve silently, see it. Okay, I once solved it, but I saw something wrong in this question. Okay, so one time more. Okay, so first, okay, solve it. I don't know what the output will come, just trying. Okay, so f of t, it is given f of t cos of t minus 2 pi by 3 into t greater than 2 pi by 3. Clear? When t greater than 2 pi by 3 and 0 when t less than 2 pi by 3. Clear? Clear. So here you can see that a limiting condition has been shown. Okay, fine. So integration mandatory. So we know L of s equal to 0 to infinity to the power minus st f of t dt. I think you all know that. Okay, okay, now I will split this in two limiting range. Okay, so 0 to 2 pi by 3 e to the power minus st f of t into dt plus 2 pi by 3 to infinity into e to the power minus st f of t dt. I hope it's clear to you. Okay, now if you can see that here 2 by 3 is highest range, so this term will be 0. Okay, and this term will be cos t minus t pi by 3, and here f of t will be replaced by this term. Okay, so the limiting value is coming L of s equal to 2 pi by 3 to infinity. Okay, 2 pi by 3 to infinity e to the power minus st into cos of t minus 2 pi by 3, okay, cos of t pi by 3 dt, clear. Okay, now here cos a minus b, I can split it 2 pi by 3 infinity minus st cos a minus b equal to cos a cos b plus sin a sin b. Okay, so cos t cos 2 pi by 3, okay, plus sin t sin 2 pi by 3, clear. Okay, into dt. Okay, now here we know the value of cos 2 pi by 3 and sin 2 pi by 3. Okay, just substitute it. Okay, so 2 pi by 3 to infinity, okay, e to the power minus st into cos t cos 2 pi by 3, so here's value minus 1 by 2 plus sin t into sin 2 pi by 3, it's value root 3 by 2 into dt, clear. Now minus 1 by 2 2 pi by 3 to infinity e to the power minus st cos t into dt, clear. Okay, plus root 3 by 2 2 pi by 3 to infinity e to the power minus st sin t dt, clear. Okay, now I am considering these two integration by I and I dash. Okay, so minus 1 by 2 I plus root 3 by 2 I dash, clear, where I equal to 2 pi by 3 to infinity e to the power minus st cos t into dt, clear, and I dash equal to 2 pi by 3 to infinity e to the power minus st sin t dt. Now I am going to solve these integrations individually. Okay, so I equal to e to the power minus st cos t dt. Okay, not take bypass. Okay, so cos t integration of e to the power minus st dt minus integration of ddt of cos t, so minus sin t, okay, minus sin t, and integration of e to the power minus st dt, and this is the whole integration of dt 2 pi by 3 to infinity 2 pi by 3 to infinity 2 pi by 3 to infinity. So this is the bypass. Okay, fine. Okay, now calculate it. Okay, so here we can get cos t e to the power minus st, here the integration with respect to t, so e to the power minus st by minus s. Okay, so here 2 pi by 3 to infinity, clear, minus 1 by s, because e to the power minus st infinity, the integration of e to the power minus st equal to e to the power minus st by minus s, so e to the power minus st minus s minus minus plus plus minus minus. Okay, 1 by s, okay, sin t, okay, minus 1 by s sin t, and after that you will get sin t to the power minus st, and after that you will have to calculate again the bypass. Okay, because from here you will get 2 pi by 3 to infinity e to the power minus st sin t dt, clear. So minus 1 by s sin t e to the power minus st dt, clear. Okay, plus 1 by s cos t sin t cos t, okay, e to the power minus st, and here to be minus st integration of e to the minus st, so e to the minus st by minus s minus minus plus 1 by s, okay, dt, clear. So limiting value you all know, 2 pi by 3 to infinity 2 pi by 3 to infinity, clear, clear. Okay, now if you substitute the values, e to the power minus infinity equal to 0. Okay, so cos so here this term will be 0 minus 2 pi by 3 will be substituted. Okay, so here one term minus cos 2 pi by 3, okay, e to the power minus 2 pi s by 3 by minus s, so s plus, clear, fine, minus 1 by s. Okay, from here we can see that this term, okay, so 1 by s sin t e to the power minus st, okay, so sin t e to the power minus st by minus s 2 pi by 3 to infinity, and here 1 by s and minus 1 by s, so minus 1 by s square minus 1 by s square, and you can see that cos t e to the power minus st dt e to the minus st cos t, so I, clear. Okay, now you can write this term, bring it in the LHS. Okay, so I plus 1 by square into I, clear, so man here you can write cos 2 pi by 3 equal to minus 1 by 2, so minus 1 by 2s e to the power minus 2 pi s by 3, clear, minus 1 by s. If you substitute the values, okay, so you will get minus sine 2 pi by 3 plus e to the power minus s d by minus s. Okay, okay, okay. Minus 2 pi s it will be minus 2 pi s by 3 minus 1 by s to minus sine 2 pi by 3, okay, plus it will be minus 2 pi by minus 2 pi s, sorry, it is value 2 pi s by 3 by minus s. Okay, clear. Okay, so here I common 1 plus 1 by square, okay, equal to okay, equal to minus 1 by 2s e to the power minus 2 pi s by 3, clear, minus sin 2 by 3 by 3 equal to root 3 by 2, okay, so here root 3 by 2 square because s and s square, clear, e to the power minus 2 pi s by 3. Okay, so please check my signs, okay, if there's going anything wrong then please inform me in the comment box, okay, but the process is okay, fine. Now let's take, so what we have got, I into 1 plus 1 by a square, okay, equal to minus 1 by 2s e to the power minus 2 pi s by 3 minus root 3 by 2 square into e to the power minus 2 pi s by 3, okay. Okay, now you can write I equal to, here we will get a square plus 1 by square, so a square by a square plus 1, okay, I have, there's no problem, so minus 1 by 2 a to the power minus 2 pi s by 3, clear, okay, minus root 3 by 2 into e to the power minus 2 pi s by 3. So we have got the value. After that we will calculate the IDEST, okay, so the IDEST integration, here the integration IDEST to pi by 3 to infinity e to the minus st sin t, okay, so 2 pi by 3 to infinity, okay, e to the power minus st sin t dt, okay. The video is going to be lengthy, so I am trying to do speedily, okay, so think 2 pi by 3 infinity, okay, so I am changing the sign infinity to 2 pi by 3 e to the power minus st sin t dt, okay, so here minus of sin t e to the power minus st by minus s plus minus 1 by s infinity to 2 pi by 3 cos t to the power minus st, okay, plus, okay, to dt, clear, okay, so 1 equal to plus sin 2 pi by 3 into e to the power minus 2 pi s by 3 by s, okay, okay, minus 1 by s cos t e to the power minus st by minus s infinity to 2 pi by 3 minus 1 by s infinity to 2 pi by 3 into sin t e to the power minus st into dt, okay. Now you can see that this is our previous term, so here it will be replaced by IDEST, okay, so here the input the value, okay, so root 3 by 2s e to the power minus 2 pi s by 3 minus 1 by s, clear, okay, plus 1 by 2s e to the power minus 2 pi s by 3 minus 1 by s into IDEST, clear. So breaking the bracket, root 3 by 2s e to the power minus 2 pi s by 3 minus 1 by 2 square e to the power minus 2 pi s by 3 plus 1 by s square into IDEST, clear. Okay, now bring this term in the Laplace term, okay, so we will get IDEST equal to 1 minus 1 by square, clear, equal to root 3 by 2s e to the power minus 2 pi s by 3, clear, minus 1 by 2 square e to the power minus 2 pi s by 3. So IDEST equal to a square by a square minus 1, clear, okay, So root 3 s by 2 e to the power minus 2 pi s by 3 minus 1 by 2 e to the power minus 2 pi s by 3. Clear? So I have calculated the value of I and I dash. Okay, now I will substitute in the equation here 1 by 2 into I plus root 3 by 2 into I. Clear? So L of s equal to minus 1 by 2 I plus root 3 by 2 into I dash. Now substitute this minus 1 by 2 into here the value I dash. Okay, so substitute it 1 by 2 1 by a square plus 1 into minus s by 2, okay, e to the power minus 2 pi s by 3 minus root 3 by 2 e to the power minus 2 pi s by 3. Clear? Plus root 3 by 2, okay, 1 by a square minus 1, okay, into root 3 s by 2 e to the power minus 2 pi s by 3. Clear? Minus 1 by 2 into e to the power minus 2 pi s by 3. Okay, now I will calculate this. Okay, fine. Now we will get 1 by 2 into a square plus 1. Okay, second one start s by 2 e to the power minus 2 pi s by 3 plus root 3 by 2 e to the power minus 2 pi s by 3 plus root 3 by 2 into a square minus 1. Okay, so from here we will get root 3 s by 2 to the power minus 2 pi s by 3 minus 1 by 2 e to the power minus 2 pi s by 3. Clear? Okay. 1 by 2 e to the power minus 2 pi s by 3 root over 2 square minus 1 e to the power 3 s e to minus 2 pi s by 3 plus minus. Okay, now आगे बढ़े. Okay, so e to the power minus 2 pi s by 3 common 1 by 2 into a square plus 1. Okay, s by 2 plus root 3 by 2 plus root 3 by 2 into a square minus 1. Clear? Into root 3s by 2 minus 1 by 2. Okay, so man e to the power minus 2 pi s by 3 to 1 by 2 into a square plus 1 into s plus root 3 by 2 plus root 3 by 2 into a square minus 1 into root 3s minus 1 by 2. Clear? Okay, so e to the power minus 2 pi s by 3 into 2 into a square plus 1 into a square minus 1. So from here we can write a square minus 1 into s plus root 3 s plus root 3 plus a square plus 1 into 3s minus root 3. Clear? Okay, now I can write 2 pi s by 3 into s cube plus root 3 square minus s minus root 3 plus 3s cube minus root 3 square plus 3s minus root 3. Okay, so here you can root 3 square 2 into a square plus 1 a square minus 1. Okay, now I can write e to the power minus 2 pi s by 3 into 4s cube plus 2s minus 2 root 3 by 2 into a square plus 1 into a square minus 1. Okay, so here you can see that the term 4s cube plus 2s minus 2 root 3. So if I take common 2, so here I will get 2s cube plus s, okay, minus root 3 by square plus 1 into square minus 1. Okay, and the answer in the book is e to the power minus 2 pi s by 3 into this is not in the upper term, this is here because I verified in the previous publication of Rishke Das. Okay, the old version of this book, there this term is not upper term, so this is the s by square plus 1. Okay, so if you can see that here, if I this term to root 3 term did not exist, then the answer will be same as book, but I don't know what's happening. check this math. Okay, I think the answer is wrong. Okay, this is the correct answer, but if the answer is not wrong, okay, then so think about this. Okay, uh, if I have done any silly mistake, then inform me in the comment box. Okay, I will try to solve it again later. Okay, but for now, this is the answer. Okay, try it. Thank you for today. Subscribe if you think this video is needful. Okay, and next session I will start another new exercise.